Hi everyone. In the last video we learned what is machine learning. Now let's get familiar with the basic terms commonly used in this field. Suppose that we have a lot of data with us. Data is any value, text, picture, sound or fact which can be used to extract information. Let us choose this numerical data which we will be mostly dealing with. Since it contains lots of rows of data, we call it a dataset. A dataset can have as many number of rows and columns. If we plot x, y point on a graph as a dot, then it is known as a scatter plot. What we do is we pick one x, its corresponding y, and then mark the data point as a dot on the graph. We do it for all the rows and we get a scatter plot as shown. Here, all the points are following a pattern or trend, but some points are not. The points which are not following the pattern are known as outliers. Now, looking back to the dataset, we observe that we have two input variables and one output variable. Output variable is the variable which you want to predict and is dependent on input variables. All other variables except the output variable are input variables, which are also called independent variables. Here, the input variables are continuous variables. Wondering how? Because these variables in this dataset can have any possible value between a range of numbers. But our output variable is categorical as it only has some particular values. These unique values which a categorical output variable has are known as labels. Don't worry if you hear the terms like target variable or dependent variable. These are just other names for output variables. Moreover, variable in machine learning is known as feature. So, it can also be said that we have two input features and one output feature in our dataset. Now, since we give data to the machine to understand the pattern and relationship between variables, we first divide our data into training data and testing data. The testing data we get after splitting makes it easier for us to judge what a machine has learned with the given training data. After the training, we get a trained entity or a trained machine in layman terms, which is called a model. This model is used further for the predictions. Sometimes it is also said that we are fitting a model. So don't get confused as fitting just means training. Now suppose we have a trained model with us and the relationship it finds is shown by this solid line in the graph. If this line does not follow the pattern, then the model is said to be underfit. And if this line is not general and it tries to explain the trend of each and every point as shown, then the model is said to be overfit. Both overfit and underfit models are not considered good. Once we have trained the model and used it for predicting the output for our test input data, we can compare the actual answers with the predicted answers and calculate the accuracy of the model using this simple formula. That is, the number of correct predictions divided by the total number of predictions. We can multiply it with 100 also to get accuracy in percentage. Another way of evaluating the model is through confusion matrix. A matrix is an arrangement of numbers or symbols in rows and columns format. A confusion matrix is represented as shown. Now, let's understand how to read it. In the rows, we have actual labels and in the columns, we have predicted labels. The cells indicate the percentage of data for corresponding row and column. For example, for 49% of the data, the model predicted the label to be 0 and it was actually 0. For 5% of the data, the model predicted label 1 but actually the answer was 0. For 5% of the data, the model predicted label 0 and it was actually 1. And for 41% of the data, the predicted label was 1 and in actual also it was 1. So, this is how we read a confusion matrix. Now, I hope that you have understood most of the terms and will now be comfortable in using them. So, see you in the next video.